Welcome to the Explainer. So today we're tackling something that can honestly feel pretty daunting: conquering the SPEC CPU 2017 installation on Windows. If you've ever glanced at that dense technical manual and felt a wave of being totally overwhelmed, don't sweat it. We're going to demystify this entire process together. We'll be doing a super clear, step-by-step walkthrough and really focusing in on exactly what you need to type into your command line to get this absolute powerhouse of a benchmarking tool up and running.
Here's our roadmap for today. 1. Prepping for the install. 2. Mounting and installing. 3. Setting your environment. 4. Building your first benchmark. And 5. Running the full suite.
Before we start hammering away at commands, let's just quickly frame up our objective here. SPEC CPU 2017 is a highly respected, compute-intensive benchmarking software suite from the nonprofit SPEC Corporation. Now, it's absolutely crucial to remember that this is licensed software. If your institution holds a license, you're perfectly fine to install it across multiple systems internally, but it is strictly for institutional use. You definitely cannot share this software with the public.
All right, Section 1, Prepping for the Install.
Okay, let's dive right in. Our first phase is all about gathering our tools and getting the environment dialed in. You'll need to open up your command prompt because that's our home base for this entire installation. And here's a massive pro tip right off the bat: enlarge your command prompt window immediately. Visibility is literally key when you're typing out long, exact commands and trying to read complex system outputs. Just click the upper left corner of the window, hit Properties, hop over to the Layout tab, and pump up those sizes. Trust me, your eyes are going to thank you later when we're parsing through dense configuration logs.
Once you've got a comfortable command prompt, we need to handle that absolutely enormous ISO image file you downloaded. We've got a fork in the road here depending on your version of Windows. For Windows 8, 10, and Server 2012, it's super simple. Just double-click the ISO or select Mount to attach it as a virtual drive. But if you're rocking Windows 7, you'll actually need to right-click the image and select Burn Disk Image to a physical DVD. Whichever path you end up taking, pay very close attention to the drive letter that gets assigned to it. You're going to need that specific letter in just a second.
Moving right along, Section 2, Mounting and Installing. So heading into Phase 2, we're actually firing up the install. And here is a major reminder. Do not, I repeat, do not try to run the installation file from Windows Explorer. We are running this whole shebang directly from the command prompt. First, navigate to the drive letter where you mounted that ISO. Then run the installer by typing its name followed by where you want it to live. For instance, you might type install.bat C CPU 2017. That single command kicks off the process of unpacking roughly 2.2 gigabytes of files. And hey, don't panic if it just sits there and hangs for a bit. The testing phase running in the background of this script often takes way more time than the actual unpacking. Just let it do its thing.
Now, occasionally, the installation will just completely fail before it even gets off the ground. If that happens to you, the manual's appendix is a lifesaver. The most common culprit? A missing or read-only temporary directory. You can test this by typing echo %temp right into your prompt. If it literally just spits back %temp, your variable isn't set. Or if you try writing to it and get an access is denied error, you lack write permissions. But there's a super easy fix. Just type settemp equals followed by a path to a writable folder. So something like settemp equals c:/mytemp folder.
All right, on to Section 3, Setting your environment.
Let's transition over and see how we configure our specific setup to actually build things. Now that those 2.2 gigabytes are unpacked, the software needs to know exactly how to talk to your computer's compiler tools. To set those paths, we have to edit a text file. But fair warning here. SPEC CPU files have this mixed Unix and Windows lineage. If you pop these files open in standard Windows Notepad, the formatting will likely break and all the text lines are going to run together into this giant unreadable mess. The manual suggests 3 safe alternatives: WordPad, which is an awesome, easy Windows default; the MS-DOS editor, the watch out because that fails on 64-bit systems and has file name limits; or VI, which is fantastic if you're already running Unix compatibility tools on your machine.
Using whichever text editor you picked, you need to open up a file called shrc.bat inside your new installation folder. Inside there, you've got to uncomment the specific line for your compiler paths. You do this just by deleting the letters rem at the very beginning of the line. Also, the manual highly recommends setting up your environment by pointing this file to a vendor-supplied batch setup file, things like VSVARs or ICLVARs. Honestly, doing it this way instead of typing out every single path manually is so much safer. Those vendor files automatically set all the needed variables, which completely saves you from pulling your hair out over mysterious compilation errors later on. Okay, Section 4, Building your first benchmark. With our environment safely mapped out, we've reached a pretty awesome milestone. It's time to actually test our installed copy by trying to build just one single benchmark. To do this, the suite needs a configuration file which basically tells the system about your specific optimization options. Here is your micro workflow for this. First, grab a sample config file for a system similar to yours straight from spec.org. Second, copy it into your configure directory and give it a name, but absolutely no blank spaces allowed. Third, open that file up and edit the label line to an arbitrary but meaningful tag. That tag is going to be attached to your output files later, making them super easy to identify.
So go ahead and run your newly edited shrc.bat file in the command prompt to load up your environment. Then, to compile that first benchmark, you're going to type a command just like this: run CPU -action equals build -config equals followed by your config file name, and then the name of a benchmark that compiles pretty fast, like 508.namdar. Hit enter and just watch your system go to work.
Now, what's really interesting here is looking at the two possible outcomes. If you succeed, you've essentially just proven that SPEC CPU 2017 is installed flawlessly and can communicate with your C compiler. You're going to see a brand new executable file sitting there with that custom label tag you created right alongside a log file named cpu2017.001.log. But if it fails? The most common pitfalls are almost always configuration errors. You either grabbed a config file meant for a totally different OS, you completely forgot to install your compiler in the first place, or you've just got bad path text written in the config file itself.
And finally, Section 5, running the full suite. Assuming you saw that glorious success output, huge congratulations, you've crossed the biggest hurdle. We are now in the final phase, tackling an entire suite and running the real workload. So the question is, are you ready for a full reportable run? This is the ultimate test. But I do have to warn you, this extended test is going to demand some massive hardware resources from your machine. Depending on your rig and the specific suites you've queued up, this could literally take many hours. You're probably going to want to let this run overnight.
When you're finally ready to pull the trigger, the command is going to look like this: run CPU -copies 10 -reportable fprate. Let's break down exactly what that means. You're calling the tool. You're asking it for 10 concurrent copies to really stress the system out. You're demanding a strict, reportable run so it adheres to all official parameters. And you're targeting the fprate, which is the floating point rate benchmark suite.
The second you hit enter on that command, you can sit back and watch your command prompt start cycling through 3 distinct phases. First up are the test workloads. Now, these aren't timed. They're just there to ensure the system can generate a valid output without completely crashing. Next are the train workloads. Again, not timed, but they are crucial for prepping the system's memory and caches. And then finally, the refrate workloads kick off. This is the main event. These are the officially timed runs that actually produce your final benchmark score. To give you some real-world context here, on a reference system back in 2016, this exact workload for a 10-copy floating point run took about 10 solid hours.
And there you have it. You've successfully gone from staring at a massive, intimidating ISO file to running a fully functioning, reportable benchmark suite, all by commanding the system step by step. So I'll leave you with this one thought. After mastering this command line installation, what performance bottlenecks is your very first SPEC CPU 2017 reportable run going to reveal about your own hardware? Thanks so much for hanging out with me for this explainer, and happy benchmarking.